Happy New Year and welcome to the first episode of Astronomy Daily for 2025. I'm your host, Anna, and I'm thrilled to be back with you for another exciting year of space exploration and astronomical discoveries. We've got a packed show for you today, covering some fascinating developments that are already shaping up to make 2025 a landmark year in space science. We'll be looking at new regulatory changes that could accelerate commercial spaceflight, examining some concerning findings about NASA's Orion capsule, and exploring breakthrough technology that could help us detect gravitational waves with unprecedented precision. We'll also journey to the far side of the moon to learn about an innovative new way to study space debris, check out some of the most remarkable exoplanet discoveries from the past year, and get an inside look at SpaceX's ambitious plans for their Starship program. So strap in and get ready to explore the cosmos with us as we begin another year of amazing space science and discovery. In a significant move for commercial spaceflight, the U.S. Federal Communications Commission has just expanded the spectrum available for launch communications. The FCC's December 31st announcement allocated additional frequencies between 2360 and 2395 megahertz that can now be used for communications with commercial launch and re-entry vehicles. This new allocation fulfills requirements set out in the Launch Communications Act of 2024, which President Biden signed into law last September. The act called for making 3 specific frequency bands available to support the growing commercial space industry. What makes this particularly interesting is that 2 of these bands were already allocated for launch communications, but this 3rd band opens up new possibilities for both uplink and downlink communications with spacecraft. This additional bandwidth is crucial as the commercial space sector continues to expand rapidly. Both the FCC and launch companies have emphasized that this extra spectrum is essential to handle the increasing number of launches we're seeing. As FCC Chairwoman Jessica Rosenworcel noted, this move will make it easier for new competitors to consistently access the spectrum they need for their missions. The new allocation isn't without its challenges, though. The band will be shared with existing aircraft and missile testing operations, which means launch operators will need to take special precautions to avoid interference. However, companies like SpaceX and Virgin Galactic have already successfully used portions of this band for several launches without any reported issues. Perhaps most importantly, this change streamlines the licensing process for launch companies. Instead of having to apply for special temporary authority for each individual launch, operators can now work within a more efficient framework that covers all 3 allocated bands. This should significantly reduce the administrative burden on both the companies and the FCC, helping to accelerate the pace of commercial space activities. This development really showcases how the regulatory landscape is evolving to keep pace with the commercial space industry's rapid growth. As we continue to see more private companies reaching for the stars, having robust and clear communication protocols will be absolutely essential for safe and efficient operations. Next up, the safety and reliability of NASA's Artemis program faced a significant challenge when inspectors discovered concerning damage to the Orion capsule's heat shield following its splashdown in December 2022. What initially looked like a successful conclusion to the Artemis 1 mission revealed some worrying issues that have since caused delays to the program's timeline. When the recovery crew lifted Orion onto the USS Portland's deck, they noticed substantial cracks on the capsule's lower surface where it connects to the heat shield. While some wear on a heat shield that endured temperatures of around 5,000 degrees Fahrenheit might seem expected, the extent of the damage raised serious concerns about crew safety for future missions. After nearly 2 years of thorough analysis, NASA's investigation revealed that the problem stemmed from an unexpected interaction between the shield's materials during re-entry. The heat shield's design uses a specialized resin called Novolac, embedded in a honeycomb structure of fiberglass threads. During re-entry, this material is meant to gradually melt and form a protective char layer. However, what actually happened was more complex. As Orion performed its skip re-entry maneuver, the shield began melting as planned, but when the capsule bounced back into space, the outer layers froze, trapping heat inside. This trapped heat vaporized more of the resin, and during the second atmospheric entry, the expanding gases created those concerning cracks in the char structure. In response to these findings, NASA has announced significant changes to their approach. For the upcoming Artemis 2 mission, which will carry astronauts around the moon, they've modified the re-entry trajectory to prevent heat from accumulating in this way. Looking further ahead to Artemis 3, NASA plans to implement new manufacturing methods to make the shield more permeable. These challenges have pushed the timeline for crewed Artemis missions further into the future, with Artemis 2 now targeting sometime in 2025 and Artemis 3 slated for 2027. While these delays might be frustrating, they reflect NASA's unwavering commitment to crew safety as they work to return humans to the moon. Scientists have made an exciting breakthrough in our ability to detect gravitational waves, those subtle ripples in space-time that give us unique insights into cosmic events. Researchers have developed a new technique called optical spring tracking that could dramatically improve how clearly we can detect these elusive waves. The Advanced Laser Interferometer Gravitational Wave Observatory, or ALIGO, uses incredibly sensitive equipment to measure tiny distortions in space-time caused by distant cosmic events. While this technology has already revolutionized our understanding of phenomena like black hole mergers, it faces limitations from what scientists call quantum noise. This new optical spring tracking system works by tuning itself to match the frequency of incoming gravitational waves. In tests, researchers used a microscopic mirror weighing just 50 nanograms, made from carefully layered aluminum gallium arsenide and gallium arsenide. When hit with laser light, this tiny mirror creates an optical spring effect that can be precisely controlled to track and enhance gravitational wave signals. The results have been remarkable. In their proof-of-concept experiment, the team demonstrated that tracking a signal with this system improved the signal-to-noise ratio by up to 40 times compared to traditional methods. This means we could potentially detect much fainter gravitational waves from even more distant cosmic events. While implementing this technology in full-scale observatories like LIGO will require overcoming some engineering challenges, the potential benefits are enormous. By enhancing our ability to detect gravitational waves, we might soon be able to observe events from the very earliest moments of our universe, including the mergers of primordial black holes formed shortly after the Big Bang. This advancement represents a significant step forward in our quest to understand the universe's most energetic events and could help unlock mysteries about how our cosmos formed and evolved over billions of years. Next, a story about CubeSat innovation at its finest. While Earth's atmosphere protects us from most space debris, scientists are developing an innovative new way to study these cosmic impacts by watching them strike the moon. A fascinating new mission called the Lunar Meteoroid Impact Observer, or LUMIO, aims to give us an unprecedented view of meteoroid strikes on the lunar far side. LUMIO is a compact but capable spacecraft, a 12-kilogram CubeSat equipped with a specialized camera designed to detect the bright flashes that occur when space rocks impact the lunar surface. What makes this mission particularly clever is its planned position at a special point in space, called the Earth-Moon L2 Lagrange point, perfectly situated to observe the moon's far side. From this unique vantage point, LUMIO will have an unobstructed view of impacts that we could never see from Earth. And since the moon has virtually no atmosphere, these objects strike the surface directly, creating visible flashes that can tell us important information about both the impactor and the lunar surface. The numbers are quite remarkable. Scientists estimate that up to 23,000 meteoroids weighing 30 grams or more strike the moon each year. While LUMIO will only observe half of these impacts, it's still expected to detect multiple strikes every single day, building up an unprecedented database of information about the space debris in our cosmic neighborhood. Of course, operating at the L2 point presents some unique challenges. The spacecraft will need to rely on relay satellites for communication, since the moon will block its direct line of sight to Earth. It will also need sophisticated automated systems to process the massive amount of imagery it collects, capturing 15 frames every second and using smart algorithms to identify genuine impact flashes. The LUMIO mission has already been selected as a finalist in ESA's Lunar CubeSat for Exploration competition and is scheduled for launch in 2027. Once operational, it promises to give us fascinating new insights into the bombardment our celestial neighbor regularly endures, helping us better understand the threats these objects might pose to Earth and our future lunar operations. Let's take a look now at some of the strangest planets discovered over the past 12 months. 2024 has been an extraordinary year for exoplanet discoveries, with several fascinating new worlds expanding our understanding of planetary diversity. Perhaps the most intriguing find was a new cotton candy planet with the lowest density ever recorded for an exoplanet. These peculiar worlds continue to challenge our theories about planetary formation, with their impossibly fluffy atmospheres defying conventional explanation. In an inspiring demonstration of citizen science, amateur astronomers working alongside professionals discovered a remarkable planet in a binary star system. What makes this find particularly exciting is that it orbits within the habitable zone of the brightest known star to host such a planet, the region where liquid water could potentially exist on its surface. We've also gained valuable insights into planetary formation, thanks to the discovery of what may be the youngest transiting exoplanet ever found. This giant world, orbiting an incredibly young star, is providing astronomers with a rare glimpse into the early stages of planetary development. One of the year's most bizarre discoveries was a huge planet with what scientists are calling a super-eccentric orbit, more elliptical than any previously known. This peculiar world appears to be traveling backward compared to its star's rotation, potentially offering clues about how hot Jupiter's, massive planets orbiting extremely close to their stars, come to exist. Closer to home, our nearest stellar neighbor after the Sun, Barnard's star, has revealed its own planetary secret. Just 6 light-years away, this newly confirmed exoplanet adds to our growing catalog of nearby worlds and reminds us that we still have much to discover in our own cosmic backyard. Perhaps the most unexpected planetary discovery came from a simple timing discrepancy. When astronomers noticed a known planet crossing in front of its star 2 hours earlier than predicted, their investigation led to the discovery of an entirely new world in the same system. It's a perfect example of how careful observation and attention to detail continue to unveil the universe's hidden treasures. Finally, today, let's take a look at SpaceX's Starship plans heading into the new year. SpaceX's Starship program reached several significant milestones in 2024, with the company now setting its sights on an ambitious expansion of operations in 2025. The world's largest and most powerful rocket system completed 6 test flights to date, with each launch bringing valuable lessons and improvements to the vehicle's design and performance. The most recent flights have demonstrated remarkable progress, with both the Super Heavy booster and the Starship upper stage successfully surviving atmospheric re-entry. A particularly noteworthy achievement came during the 5th test flight, when the launch tower successfully caught the returning Super Heavy booster using its innovative chopstick arms, a crucial step toward SpaceX's goal of rapid reusability. Looking ahead to 2025, SpaceX has applied for permits to dramatically increase their launch frequency from their Starbase facility in Texas. The Federal Aviation Administration has given preliminary approval for up to 25 launches in the coming year, a 5-fold increase from current levels. This expanded schedule would include not just launches, but also 50 tower catches, split evenly between the Super Heavy boosters and Starship upper stages. The company is also planning significant upgrades to the vehicle itself. Future versions of Starship will feature increased thrust capabilities, with plans to achieve 3 times the power of NASA's Saturn V rocket. These improvements aim to enable the transport of larger payloads, with future iterations capable of carrying over 200 tons to orbit. Perhaps most ambitious are the cost projections, with SpaceX suggesting that the full reusability of the system could eventually bring launch costs down to just a few $1 million per flight. This dramatic reduction in launch costs, combined with increased payload capacity and flight frequency, could revolutionize access to space and support the company's longer-term goals of establishing a sustained human presence on Mars. These developments come at a crucial time as NASA continues to rely on Starship as a key component of its Artemis program, with the vehicle selected to serve as the lunar lander for future missions to the moon's surface. As we move into 2025, all eyes will be on SpaceX to see if they can maintain this ambitious pace of development and testing. That brings us to the end of today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me as we explored these fascinating developments in space and astronomy. From revolutionary advances in gravitational wave detection to SpaceX's ambitious plans for Starship, it's clear that 2025 is already shaping up to be an incredible year for space exploration. To stay up to date with all the latest space and astronomy news, head over to our website at astronomydaily.io. There, you'll find detailed articles on all the stories we covered today, plus our complete archive of past episodes. And don't forget to follow us on social media. You can find Astro Daily Pod on Facebook, X, Tumblr, YouTube Music, and TikTok. And until next time, keep looking up and stay curious about our amazing universe.